You taken it down? Is the next thing that is there. Characteristics of image. Can you mute the speaker? Speaker. Okay. So next thing that you are going to put down is characteristics of image formed by a plane mirror. I have explained you all the points. You can just take them down. So we have written laws of reflection, characteristics of image that is formed by a plane mirror. The next part that we are starting is spherical mirrors. Spherical mirrors basically they will are going to be curved mirrors. Okay, they are going to be of two types. If the reflecting surface is bending inwards, okay, it is this kind of a mirror which is there. This kind of a mirror is known as a concave mirror. If the reflecting surface is going to bend outwards, it means the rays of light are going to come and strike from this side. Then it is going to be a convex mirror. Now, how these rays are going to travel in both of these cases, in case of concave mirror as well as convex mirror, the rays of travel are going to travel in a different way. But before this, we are going to have a few definitions which we are going to note down for concave mirror and convex mirror. The first thing that is going to be there is the center of curvature. Then we are going to have focal point, focal length, the pole of the mirror. These are the few definitions that we are going to take down. I'm coming to the first part of the definition. I'll just first draw this mirror and then we are going to we are going to give all of these definitions. All right, we'll come to the definitions which are going to be important. This is a curved surface. So this is a spherical mirror. The rays of light are approaching from the left hand side. Because the curved surface is bending inwards, therefore this kind of a mirror is going to be a concave mirror. The first definition from here, the center of this mirror, which I'm marking, okay, that is labeled as point P. That is the center of the mirror. It means it is going to be the center from these 2 points, the upper point and the downward point. The middle of this point is point P, which is known as the pole of the mirror. Then the next definition is center of curvature. I marked it as C. This is the center from which the whole circle is supposed to be drawn. So that point is the center of curvature. The circular part, the circle which is being drawn, that point is known as the center of curvature. The midpoint of these two, that is this line CP. Okay, the midpoint of that point is marked as point F. This is known as the focus. This is known as the focus of the mirror. What is the speciality of this point? The very special, the special point about specialty of this point F is that whenever all of these rays that are traveling, I have also marked another line, which is this orange line. Okay, this line is known as the principal axis. What is this principal axis? It is simply the line that is joining the center of curvature and the pole of the mirror. This line is the center line that is being drawn, that is the principal axis. Now all the rays that are parallel to the principal axis, whether it is above the principal axis or it is below the principal axis, after reflection they are always going to pass through this point. Whichever ray of light is parallel to the principal axis, they all will be passing through one point only, that is going to be the focus, the principal focus of a concave mirror. Okay, so this point is the principal focus of the concave mirror. That's the principal focus of the concave mirror. Now some distances. Okay, the next definition that I am taking over here is the distances. The distance CP, which I have marked in blue color, that is the distance between the center of curvature and the pole of the mirror. This distance, which I have marked in blue, this is known as radius of curvature. Okay, I'm just repeating the definition. The blue distance, this distance that I have marked, this is known as radius of curvature. This distance is between the center of curvature and the pole of the mirror. Another distance that I'm going to consider, I'll mark it with different color. Okay, I'm marking it this with pink color. This distance is between F and P. This distance which I have marked in pink, this distance is focal length. Okay, so what is focal length? Focal length is the distance between the principal focus and the pole of the mirror. So these are all the definitions that are going to be important. Then we are going to have several ray diagrams. 5 ray diagrams are going to be there depending upon the position where you are going to place the object. Okay, the object can be placed at infinity, the distance which is very large compared to the focal length, that is going to be the when the object is at infinity. Another position is the object is in close proximity. The object can be placed over here at this point. This is beyond center of curvature. It means this distance is more than the radius of curvature. Next part is where the object is going to be placed at the center of curvature. This is going to be the third position. First position is at infinity. Second position is beyond center of curvature. This is the third position that I have marked, which is at the center of curvature. The fourth position is going to come over here when the object is between center of curvature and the principal focus. The next position of the object to draw the ray diagram is going to be when the object is at the focus, when the object is placed at the principal focus. And the last one of this is when the object is between focus and the pole of the mirror. So these are all the ray diagrams that we are going to draw in the next class. Not today, it won't be possible. So in the next class, we are going to draw all of these ray diagrams. I'm going to draw each one of these ray diagrams with measurement on screen on scale. You will have to keep your scale ready with your notebook and of course with your entire geometry box. Okay, so these are the things that we are going to do. One of the ray diagrams I am going to show over here where the object is beyond center of curvature, and afterwards we are also going to write down what are the characteristics of this image formed. So the first ray diagram I am going to draw, you are simply going to take your notebook. If you have your protractor and your scale, then you can take it so that you can then take down the things. Okay, so the basic diagram I have drawn. I have drawn the curved surface. This radius is 6 centimeters. Okay, so this distance CP is 6 centimeters. So you are simply going to draw a straight line, mark a point over here, draw a curved part with radius 6 centimeters. After doing that, this part is 6 centimeters. Mark at 3 centimeters the focus. And this is the basic structure that we are going to get. After this, we are going to draw all the ray diagrams. So this is the first thing, basic thing that you are going to do. And then I'll show you the diagram where the object is placed at the center of curvature. Just do this much and then we'll continue ahead. So you have drawn these lines at some distance, say about 1 centimeter away from C. Through these lines, okay, you are going to draw, suppose this is what I have drawn. See 3 lines above this line in your notebook. This is your position of the object. The position of the object is beyond C, that is beyond center of curvature. The first ray that I am going to draw, okay, I'm going to show it with a different color. Okay, this ray is parallel to the principal axis. Okay, so this is the ray that is parallel to the principal axis. I'm also going to make you write the laws to draw these ray diagrams, how these rays are going to pass through. So the first ray, the purple ray that I have shown, this ray is parallel to the principal axis. Any ray that is parallel to the principal axis after reflection, it has to pass through the focus. Okay, so this is the ray that I am showing. With the same color I will be showing so that you come to know that which ray is going from where to where. So this is the ray, a ray that is parallel to the principal axis. Always mark that with an arrow. It is passing through the focus or the principal focus after reflection. Then I'm going to show the second ray. This ray I'm drawing with again a different color. From the top point of the diagram, from the objects, I am making it pass through the focus. Okay, the blue ray that is there, it is passing through the principal focus. So this is the principal focus, the top point of the object. This is the ray, that is the blue ray that I have drawn. This is the second rule that I'm taking up, that is the ray passing through the principal focus after reflection becomes parallel to the principal axis. I'm going to show with the same color, the blue ray which is there after reflection, this ray is becoming parallel to the principal axis. Okay, I'll just mark that also with the arrow. The ray that is passing through the principal focus, after reflection, it becomes parallel to the principal axis. Now, this is the position where the purple ray and the blue ray after reflection, where they are meeting, not before reflection. Okay, that is going to be the position of the image that is produced. So the intersection of all of these points is going to be the position of the image formed. So the black image that I have marked, that is the position of the image. I'll just mark these points AB as the object and A dash B dash as the image. Okay. I'll just in short, I'll tell you how these rays are traveling. The purple ray. The ray traveling parallel to the principal axis passes through the focus. This is the first ray that I have drawn. The second ray that is there, the ray that is passing through the principal focus after reflection becomes parallel to the principal axis. The point at which the reflected rays, the purple ray and the blue rays meet, that is the position of the image. Now we are supposed to write down the characteristics of the image. The first thing is that the image is upside down, it is inverted. So therefore, of course, it is a real image. Second thing that we are going to talk about is the size of the image. You can see here the size of the object is bigger, the size of the image is smaller. So the image is diminished. Okay, this is the next characteristic. Then the last one is what is the position of the image. When the object is beyond center of curvature, the image is formed between center of curvature and the principal focus of the mirror. These are the characteristics of the image formed by a concave mirror when the object is placed beyond center of curvature. I have recorded everything. I will upload it, send you the link once I upload it.